Okay, so in this video, okay, we're not doing any graphing. We'll revisit that very soon. Okay, what we need to spend a little bit of time with might seem a bit boring. We're just filling out charts and learning different rules and things like that. But again, okay, this sets the tone for a lot of what we do in grade 12 math. So we have to get this under our belts first. And what we're going to do here is we have equations which match up with mapping notations and then a description of the changes that are actually happening in your graph. So what we need to do right now, okay, is we need to take a look at getting some practice for doing things like this. If you're given the equation, come up with the mapping. Given the mapping, come up with the equation. Given a description, come up with both. So let's get some practice filling out the missing pieces for this. So what I have here is basically 4 examples that go horizontal. So in each horizontal line on this chart, I'm giving one piece of information and I'm going to find the other 2 pieces. So essentially what works with these ones is that what you have to do is when you create a mapping notation, and hopefully you can all see this is going to have to be written a little bit smaller. But when you do a mapping notation, okay, all the X stuff shows up in the middle. All the Y stuff shows up at the beginning and the end. And all the vertical stuff, the Y stuff, all right, those numbers don't change. So if you look in this example, we have a -2 in the beginning, a -4 in the end. We don't flip or change signs for any of those, so we keep those as they are. The X stuff does flip. So what we do is what comes after the X in the equation, we change the sign of what comes after that. So in this case, we have an X plus 1. In the mapping notation, we have an X minus 1. And the mapping notation tells us exactly what's happening. So we know we have the horizontal translation, the vertical translation, and the vertical stretch. In the equation, there's nothing in front of the X, so there's nothing to flip over to put in front of the X in the mapping notation, so there's no horizontal stretch. But we have 4 things happening here, and I don't even know if I can fit them in this box here, but I'll try. We have a horizontal translation, 1 unit left. Remember, your translation should have a number and a direction. So don't just say -1. Okay, you want to say 1 unit and indicate that that is to the left because it's horizontal. Your vertical translation for this is 4 units down. And that's because vertical comes after the Y. Negative would be down, positive would be up. So this graph has 2 different translations. There's also a vertical stretch of 2. Now we don't use -2 because the negative is something different. It's a reflection. Now I could write down VS equals 2. If you see this written in a verbal description somewhere, okay, you'll probably read it as the graph is stretched vertically by a factor of 2. And what we mean by factor of 2 is that it's going to be twice as tall. Okay, if it's vertical, it's up or down. So your new graph is going to be twice as tall as the original graph. And then because there's a negative in front of the Y, what we said was there is a reflection around the x-axis. So I have difficulty writing all these things down in actual complete sentences or even sort of complete sentences here, okay? But you would say there's a reflection around the x-axis. And remember, that's what we said. If the Y is negative, it flips over the X. If the X is negative, it flips over the Y. Moving to the second example, and feel free to work ahead of me here or pause this video and try this on your own. But in this case here, okay, we have 1/2 X plus 1. So the number in front of the X we flip over. The number after the X we just change the sign. The Y values don't change, so you have a 1/2 Y, and then there's nothing at the end of this equation here, so there's no vertical translation to put in here. Sometimes a graph doesn't have both translations and both stretches and reflections. Sometimes it only has some of these things, which is happening here. So in my verbal description or my written description here, I would say there's a horizontal stretch of a 1/2, vertical stretch of a 1/2, or you might want to write it in a little more detail and say graph is stretched horizontally by a factor of 1/2, and same thing with the vertical stretch. And there's also a movement of 1 unit to the right. So there's a translation horizontally of plus 1, and that comes from the horizontal translation. There's also a reflection, and I don't really have room for this, so that's a problem. Maybe I should have done less examples here. But anyway, we're going to keep rolling with this. This is a reflection around the x-axis because the y is negative. And then finally here, okay, well, actually not finally, we're only halfway done. But hey, let's do this one a little bit quicker. Okay, we have a horizontal translation, vertical translation, vertical stretch, no horizontal stretch, no reflection. So in this case right here, okay, we would say vertical translation, 1 unit up. We would have horizontal translation, 3 units not right. That would be left. Remember, the mapping notation tells us exactly what's happening. We have a vertical stretch factor of 2. So this graph is going to be twice as tall, and no reflections, no horizontal stretches, so you don't need to indicate that. And then if we make our equation from that, what we can say right here is we have the 2 and the plus 1. Remember, all the vertical stuff happens at the very beginning and the end of the equation, and those numbers don't change. But the x minus 3 turns to x plus 3. And then finally, for this one, we have a description, and we need to move backwards. I would recommend doing mapping notation first. Just a reminder that mapping notation is exactly what's happening in the description, so we shouldn't have to flip any numbers around or anything here. So what I'm going to do right here is I'm going to say, okay, horizontal translation of 2 units to the left. That's x minus 2. We have vertically stretched by a factor of 3. Vertical stretch goes in front of the y. And a reflection around the x-axis means the y is negative, so I'll put a negative in front of the y. Okay, so those are the 3 things that are happening. Now, to make that into an equation, we're going to have to flip some things. So the minus 3 stays as it is, and then there is nothing at the end of this equation because there's no vertical translation. We do have x minus 2 becomes x plus 2. There's nothing in front of the x, no horizontal stretch to flip over for the equation. And there we have it. So in the next few pages on your Brightspace, okay, you'll notice that there are some practice charts to fill out. And this is going to help you for the rest of this semester.